Well, in the last lecture, we have seen that how the generalization and specialization, aggregation and the grouping abstraction mechanisms can be used to model complex interrelationships among objects as well as to create a complex object. To illustrate that one more further, let us continue with our example of the university example which we had started. So we had seen in the previous class that we had the university was thought of being composed of several departments, and a department in turn was being thought of being composed of or department, and we had student, teacher, staff as certain entities which are of interest, and there are another entity called the facility, and we had seen that the university we have contains has the relationships 1:n. So in a department, in a university, there were 1:n, many departments. In a department, we allowed more than one student to be registered. There were several teachers in a department and the several staff. Now, also we looked at that head of the department is, each department has a head of the department who is a teacher. Again, we can think it of that each department is offering several courses, and so if I look at that in a department several courses are being offered. So course as an entity and each course has a unique name associated with it as a name, and the course may have course ID and so on. And however, a course, whenever we think it of a course may be taught, there may be more than one student may be registered into the course. So again, we have a relationship that in a course there is a 1:n relationship, and let us say the relationship between the teacher and the course is that, let's, for the sake of argument, there is one teacher per course, that's only a single teacher teaches a course. So we can now look at, you can see therefore the same class is being, when we are modeling university, the same class student is related to the department class as well as to this course class, and again there is an association relationship between the department and the course. So this means a department is offering this course, student is registered into the course, and the student belongs to the department. Again, it may be the case that student may be a course, we can again generalize this concept that we may allow a student from other departments also to be registered into a course offered by a third department. So in a complex information systems, when we are trying to model using object-oriented framework, the structure of the university as a class, therefore, when should be realize can be described by by the interrelationships of different types, like which can be with the help of generalization, aggregation and association of other classes, and each of them in turn may itself be a composite object. At the lowest level of the hierarchy, we may have very simple objects in which with the objects or the class will consist of only few attributes and no further subdivision is possible. So this actually defines this type of diagrams of the object diagram will define the structural relationships of a class. And if you remember, we had talked when we started with the definition of an object of a class, we say that a class has a structure as well as behavior. In this type of relationships which we have mentioned, we have concentrated mainly on the structural relationships, and the different structural relationships, to repeat, are generalization, specialization, aggregation and grouping. When we will come back to the dynamic object structures, we'll introduce new concepts called events and states to capture the dynamic behavior of the object. In the next we will consider there now, and that will go back to the concept of inheritance, and we'll see what about the behaviors. We have, when we talked about inheritance, we essentially talked about the inheritance in the subclass, the properties of from a parent class. Now, when but the properties mean not only the attributes but also the operations supported by the parent class. So these properties also will be inherited in the child class, and how therefore when we call from an external world that some of the operations of the children class, should we therefore identify them by say unique name in each subclass, or we will use the common name whatever be the class in which it is class with the common name which is present in the superclass of the class hierarchy, and resolve them at the time when the execution takes place. Now this idea itself is related to the concept of polymorphism, and which we have briefly mentioned as one of the main characteristics of object oriented modeling. And so therefore, if you recall, when we talked about objects, communication among the objects, we should remember I mentioned that exists a sender object and the receiver object, and the sender object sends a message to the receiver object, and the receiver object on receipt of the message will execute the method associated with it. And the question therefore comes, so for instance, if the sender object sends a message to a triangle object, rotate, then this rotate function, the corresponding rotate method or operation will be executed to rotate the triangle x by an angle theta. The problem of the polymorphism, as we have mentioned earlier, is that by given a common name rotate and to the receiver objects, now the receiver object can be a triangle, maybe polygon, maybe a rectangle, and then rotating an appropriate object depending upon the particular instance we are interested in will be of great use and will have considerable advantage while modeling as well as reusing a code. So this idea therefore, the definitions of the polymorphism as we mean, polymorphism means that the different forms, here the sender of a message did not know the class of the receiver object. This is very important. For instance, we had been talking earlier about the class hierarchy. Suppose I have a class hierarchy of the geometric objects like this, that suppose we write the class hierarchy as the geometric objects. Let's say we have defined a class of geometric objects like this. This is a closed objects, and these are open objects, open segments, and under the closed objects we have different classes, say polygon, we have ellipse, and under the polygon we have a special class called triangle. We may have another special class called rectangle, and so on. In this case we have a special class called this circle. And suppose now a method or operation called the area and perimeter are two operations which are, or the functions are defined with the closed objects. That is, each closed object will have an area and a perimeter, and there exists a function called area which estimate area, which will estimate the objects the area of a closed object. Now, as for since we have talked about the inheritance, single inheritance, in this case is a problem of single inheritance. So therefore, polygon also being a closed object will also have an area and a perimeter, and triangle also will have an area. Now, the way we estimate, or the code that we estimate for finding out the area of a triangle will differ from the way the area is computed for rectangle. So therefore, when the area, the function is used in this case in triangle area. Now in this we know that the area of a triangle, the formula is quite well known, or similarly in the case of a rectangle. But suppose an object sends a message called area of closed object of an object x, where x is it has a certain type. The type will be, and x can be of the type closed object, it can be type of polygon object, it can be type of triangle or a rectangle. But we are interested that depending upon the type of x, the appropriate method area will be used to compute the area of the object x. So while estimating the area, we are not using different names. So in other words, the same name is being used or overloaded for the term in different objects, and the sender object, which wants the area to be estimated, need not explicitly state which area function is to be used for computing the area of the object. Rather, depending upon the type of the object, the appropriate code or appropriate function is to be used for computing the area of that object, of that geometric object. And this is what is meant by polymorphism. And there can be different types of polymorphisms. Some of the examples are that we call inherent polymorphisms, that is, operations are inherited by subclasses, as I have mentioned. We can also allow different operations on different types have the same name. This is, of course, may sound to be funny, but in some applications it may be of usage. And again, when you have the same name being used at the different contexts or the different places, one has to appropriately resolve and find out which one to be explicitly used in a particular case. Now, moment we have the concept of polymorphism, or we support it, the idea of the message and method binding, as I was mentioning, it can be done in two ways, that is either by statically or dynamically. In case of a static, what we mean is that before executing when the code is being executed, the compiled, at that time itself, the 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 typical that the triangle area will be used if x is of triangle code, that code will be used, that function will be called. Whereas in case of a dynamic binding, it will be depending upon the type to which x will be bound, it will decide which code to be called while estimating the area of the triangle. They both has the advantage and the disadvantages, whereas the static method of binding, although appears to be simple and it often leads to better code optimizations, but it often reduces the flexibility. In case of a dynamic binding, on the other hand, the environment provides much more flexibility, although it may sometimes be more complicated to implement. So, depending upon the programming environment languages, as we will see, will support different types of polymorphism and or the types of binding, and as we will elaborate with the particular programming language, we will examine what type of binding it is supported in that environment. So, to recapitulate, therefore, polymorphism is a scheme by which what we do is that we allow the sender object not to be aware of the class of the or the operations exact code that is to be used for executing the method in the receiver object. That is, what method receiver object executes as a consequence of the method message being sent is left to the receiver object itself. So, therefore, when the receiver object receives the message, it decides among the different possibilities which one to be used, and depending upon that it can be done either statically or dynamically. And so, we have the concept of static or dynamic binding of message and method. The next concept, which we will also discuss how this polymorphism is affected in that, is the concept of abstract class. We have so far seen this is a feature which is often it's supported in many programming languages like C++, like Java, Eiffel, and also in X and C++. It is a class that does not have direct instances. If you recall, we have said that a class is essentially consists of all object instances which have the common properties. So, instead of allowing a class to have a direct instance, what we treat now this class as something like a template. So, therefore, this abstract class we define certain attributes, certain properties, functions it will have, but do not allow any specific code or rather instance that can be instantiated with it. For example, we can allow a closed object to be an abstract class, because after all a closed object without unless it is something very specific, it is difficult to envisage. And so, rather than when we go for a specific subclass of it like polygon or ellipse which are easy to draw, then we allow instances of these subclasses. So, therefore, a class that does not have direct instances, we will treat a closed object as an abstract class, and a subclass of an abstract class like say closed polygon is a subclass, and which will be allowed to have a concrete instances. So, a subclass of an abstract class may have instances, and abstract classes, as I said, are used to define methods to be inherited by subclass. So, basically we can define a method area or a parameter in a closed object and then specialize it specialize it in its own subclasses, so that we can have a different method, that is we same name area will be used for computing the area of a triangle or a rectangle. However, the methodology that will be followed or the exact code that will be followed will differ depending upon whether we are using a triangle or a rectangle. To illustrate this one, let us take the example of a, we have denoted the closed object by a diagram. So, here we define abstract class diagram. We are associated we are sitting with a two attributes which will denote by dimension 1 and dimension 2. I am using the types as float. For let us not concentrate on the syntax, although this we have followed the Java syntax. And then this function, which is the diagram float, essentially creates an object of class diagram. So, we have x is of dimension 1, y is equal to dimension 2. So, when we are given the value x and y, we create a dimension 1 and 2 values. And then you look, we have defined a class called abstract float area. In this case, the area function is not given, only the name area has been given, and that will not exist any instance of this class. So, this is an example of an abstract class. Class does not have direct instance. So, no instance of this class will exist. However, when we look at a subclass, for instance, we have a class triangle extends diagram. This is a subclass. So, therefore, triangle is a subclass of diagram. It will be possible to have two instances of the triangle, and then we call triangle float x float y super xy. This is where we are really creating the triangle, and after that here we are extending we will find area computing, allowing area of the triangle to be created. How? We are return dimension 1 and dimension 2 by 2. So, note the dimension 1 and dimension 2 are essentially the two attributes which are inherited by triangle from its parent class, and here we mean that these are the two this is one, when we compute the area, we say that is the half of the height and the base. So, we assume that the dimension 1 represents the base, say, and dimension 2 is the height of the triangle, and therefore, the area of the triangle will be dimension 1 in times dimension 2. So, here is a case, we will come back when the language Java is, or the other specific example is taken, is that we have a class diagram which does not have diagram instances. We will have a class triangle which essentially extending or is a subclass of the diagram. It inherits from the class diagram the properties or the attributes dimension 1 and dimension 2, and then it is possible to have instances of the triangle, and then once we have the instances of the triangle, also the area what we have defined here, there was no code how to compute the area of a diagram, any arbitrary diagram, it's no mathematical formula exists. However, when we come to the triangle, we say that let us say that the area of the triangle is this. So, this is what is meant by abstract classes, and what are the abstract classes are used to define methods to be inherited by subclasses. So, we needed the method area, we needed the method, similarly we can define parameter and so on, which will be inherited by its subclasses. So, after this introduction of the basic concepts of object modeling, we need to look at few other properties on object modeling and of the objects. One, as we will go into the different programming language environments that are being supported, you will see that every object oriented environment we have to have some method which we will call for creation of an object. So create is an operation which we will see will be supported or available with any class which essentially creates an instance of that class. So if you have a class A, then in the class A we will have a method called create. Now this create will essentially return an instance of the class A. Sometimes these type of methods are written by the name itself, that is the diagram in this example we had said diagram float xy, essentially it will be given, or triangle xy, it will be used to create an instance of that class. Similarly, some languages will also destroy or delete an instance. You recall we have said that an object, whenever it's created, it will have its unique object ID. So create, whenever you are creating an instance of a class, it will be given a unique ID, and this instance will remain in existence till you either we explicitly delete or some other mechanisms is used for destroying it. Now some programming languages may not explicitly support delete operations. The reason being that, say for instance like in Java, we say that whenever an object there is no reference to a particular object, we will say that that object ceases to exist. So when we will come to those specific cases, we will describe that, but the concept of creation of an object is very important, and this method, which is very the most important method in any class specification, would be that to give one instance or unique instance of a class, and each time we create an object we will essentially provide a new object instances. The next concept which often we'll have to deal with when we have the objects is the concept of what do you mean by equality of objects, because after all in many programming environment we have to see when we have to compare objects. Equality is one such feature. If you remember in our programming languages like C, we say that if x is equal to y, then say we write z equal to u plus v, else you write something else. So this is how the code in any programming environment we may have to compare the different variables or the instance or the with variables or variable with a constant of the same type. Now when we go for a programming in object oriented environment, the objects may not be very simple type like float or int. We may have a very complex object like say university. For example, we had talked about it earlier that we had university situations in this model. Now suppose I have I want to compare two universities in some way, that for instance we say that if the two universities have the same set of departments, then we can look at how many students are there in those two departments. So if you want to compare therefore objects which are such as complex as an university or a department or a course, then we must understand what we mean by object equality to begin with. Like in this case, what is meant by x is equal to y, and in this context there are different notions of object equivalence. One is the name equivalence. Example wise, say if the two objects have the same name. Now this idea may be useful in case of a university, where we can say that naturally if the two universities have the same name they will be equal, assuming of course in the world no two universities have the same name. However, we cannot say the same is to be true when we have the two student or the teachers. So these two students may have the same name, yet they may be totally different objects or different persons. Same is true with the teachers. Another concept of object equivalence may be the structural equivalence. That is, the two objects have the same structure. However, we are not interested whether they have the same behavior or not. This concept of structural equivalence is often used in case of object-oriented databases also, and to compare two objects to be equivalent, that is, they have the same structural features. Then we talk about the structural and the value equivalence. That means both of them have the same structure, as well as the value of each of the attributes are the same. And lastly, with the concept of identity equivalence. If you remember that whenever we are talking about object-oriented databases, with each instances of an object we associate an identity. Now therefore, when we will talk about the two objects to be equivalent or same, when we say x is equal to y, like in this exam environment, when x and y are instances or are the variables which are of the same having the same types, that means same belong to the same class, then x will be equated to y, provided x, the identity of the object x and the identity of the object y are the same, that both of them have been assigned to the same objects, or both of them refer to the same objects. Then and then only we will talk about their equivalence. So in many object-oriented systems, the different concepts of the equivalence or equality of the objects are supported. The most stringent one is, of course, identity equivalence, as we have seen in an object-oriented database environment. Each object will have a unique object ID, and therefore, when these two are the same, therefore they will be naturally treated as equivalent or identical. On the other hand, the structural equivalent it is fairly possible that the two objects may have the same structure, yet they may be totally different. That is, their values may be different. Similarly, it is possible that the objects may have the structural and value to be different, but they may completely belong to the two different classes. And lastly, the name equivalence, which, as we have mentioned, is the very simplest of all, which means that the two objects have the same name only. However, they may not have the equivalent type, even if you have the same name, because they may have a different structures. For example, the student, a name of a teacher and the name of a student may be the same, yet the structure of the student and the teachers are completely different, have the different structures and the different values depending upon the way you have defined. So what we have done so far, therefore, is that we have defined the different notions of how to build an object. We started with the definitions of a class, we started with the instances, we have seen how to class, instance, we have looked at the properties, how the objects in interrelationships, we have looked at the object behavior on which we have said that will be defined by an object communication. So all these features must be stated when we try to model an object-oriented database or object-oriented information system or object-oriented design. Question comes that which are the objects or what are the classes of interest, how to identify them, That is, how from the user specification, how do I identify what are the classes of interest, what are the interrelationships are, and how the different classes will communicate is an is the most crucial part in any object oriented based design, and it will require a detailed analysis of the user specifications, and then creating the from the user specification developing the object model, which will be discussed later on by my colleague Dr. Sarkar. And there are different methodologies of approaching the object, developing the object oriented analysis and design of the object oriented system, but the basic concepts which are required will be utilized, and the idea that we have described here will be utilized in that environment. What we will be doing later on is that we will now look at the one more feature in the next class. We will look at the features or what are the how to go dynamic how to capture the dynamic aspects of the objects, dynamic behavior or dynamic objects, how to model them, and then the next class where after that we will look at object oriented programming languages. Now in these, as I have mentioned in the beginning, our target would be first of all to look at what are the basic features of the any object oriented languages, how they are really supporting all these concepts of we have introduced, do they support all these features we have introduced, and then go into the any specific language, and we will be focusing our attention to the language Java. So we will see that in Java how the concept of how the classes are defined, how object relationships are captured, how does it support the concept of encapsulations, how polymorphism is supported, and then other features which are very specific to Java will be dealt with.